Question 8. Part A of the question says prove that 2 cot 2x plus tan x is identical to cot x. X is not equal to n pi over 2. N is a member of the integers, so n is a whole number. With these types of proof questions, you can either start with the left hand side and end up with the right hand side, or you can start with the right hand side and end up with the left hand side. Both ways will be acceptable. With this particular question, I think it's easier to begin with the left hand side, which is equal to 2 cot 2x plus tan x. We know that cot x is equal to 1 over tan x, so cot 2x is equal to 1 over tan 2x. You're given the addition formulas in the formula booklet. Tan of a plus or minus b is equal to tan a plus or minus tan b all over 1 minus or plus tan a tan b. If we let a and b both equal to x and use the plus component here, then we will have tan of x plus x, which gives us tan 2x equals tan x plus tan x, which is 2 tan x, over 1 minus tan x times tan x, which is tan squared x. Here we have 1 over tan 2x, so we can imagine tan 2x being tan 2x over 1. To get 1 over tan 2x, we can flip this upside down, so we must do the same with the other side. So 1 over tan 2x will be equal to 1 minus tan squared x over 2 tan x. Substituting that into here would give us the 2's cancel out, so we have 1 minus tan squared x over tan x plus tan x. Tan x we can think of as being tan x over 1. So to get a common denominator to add these two together, we need a tan x on the bottom. So we times the top and bottom by tan x. So this term becomes tan squared x over tan x. We have a common denominator, so we can now add them together. So we have 1 minus tan squared x plus tan squared x over tan x. The minus tan squared and the plus tan squared cancels out to give 1 over tan x, and we know that this equals cot x, which is the right hand side. So we've started with the left hand side and shown that it's also equal to the right hand side. So it's the end of proof. Part B says hence or otherwise. Well, we know it's not going to be an otherwise question. It's going to use what we've just done in part A. Solve for x between minus pi and pi. 6 cot 2x plus 3 tan x equals cosec squared x minus 2. Give your answers to 3 decimal places. The equation we are solving is 6 cot 2x plus 3 tan x equals cosec squared x minus 2. In part A, we just proved that 2 cot 2x plus tan x is identical to cot x. Using this, if we multiply both sides by 3, we get 6 cot 2x plus 3 tan x equals 3 cot x. So the left hand side of the equation is equal to 3 cot x. So our equation becomes 3 cot x equals cosec squared x minus 2. We now need to remember the identity that sine squared x plus cos squared x is identical to 1. We can form 2 other identities from this, either by dividing by sine squared x or dividing by cos squared x. If we divide everything by sine squared x, we get sine squared x divided by sine squared x equals 1. Cos squared x divided by sine squared x is cot squared x. And 1 over sine squared x is cosec squared x. This is what we replace this part of the equation with. So our equation now becomes 3 cot x equals 1 plus cot squared x minus 2. Moving all terms onto one side and having 0 on the other side gives us cot squared x minus 3 cot x minus 1 equals 0. This is what I refer to as a disguised quadratic. So if you can't solve it from here straight away, try letting y equal to cot x. Then y squared will equal cot squared x. So this equation will now look like y squared minus 3y minus 1 equals 0. We can't factorize this, so we can use the quadratic formula. Remember, a is 1, b is minus 3, and c is minus 1. The quadratic formula gives we can simplify this to get 3 plus or minus root 13 all over 2. So either y equals 3 plus root 13 over 2 or y equals 3 minus root 13 over 2. But remember, we let y equal to cot x. So these equations are now cot x equal to this and cot x equals this. Cot x is 1 over tan x, so we can write these as flipping this upside down and flipping this side upside down gives us tan x equals 2 over 3 plus root 13 and tan x equals 2 over 3 minus root 13. To find x, we take arctan of this side. So x equals tan to the minus 1 of 2 over 3 plus root 13. Using a calculator, our x value is 0.294 to 3 decimal places. But tan repeats every 180 degrees, so we can add or take away 180 degrees or pi to get our second solution. But x has to be between pi and minus pi, which is 3.14 and minus 3.14. So we can't add pi to this, it will fall outside of our range. If we take away pi from this value, we get minus 2.848 to 3 decimal places. Putting this in your calculator, we get minus 1.277, and adding pi to this value gives us 1.865.